I'm here at Siding Spring Observatory in Coonabarabran, Australia, and I'm in front of the dome of the Anglo-Australian Telescope. In addition to being Australia's largest telescope and one of the most significant in the world in terms of research that is being conducted here, this dome serves as the counterpart for the Sun in what was, when it was built, the world's largest solar system drive or model solar system. The dome is 1/38 millionth the size of the Sun. So fiberglass models have been constructed for each of the planets that are 1/38 millionth the size of the planets, and they have been dotted along nearby roads on a scale, approximately the right scale, 1/38 million, although in some cases more approximately than others. So that means that Mercury is just over a kilometre away. Pluto is about 200 kilometres away. If you drive between them at the speed limit, which varies but averages about 100 kilometres an hour, you are going the equivalent of 3 times faster than the speed of light going through the solar system. Now, unlike with the planets, you have to use a bit of imagination here because the dome is not coloured like the Sun, but it's the right size for the scale of the model. The Sun is a larger than average star, but it's by no means exceptional among stars. There are ones many times more powerful. But despite that, it's worth reminding ourselves sometimes just how powerful this is. Every second, the Sun produces 3.8 times 10 to the 26 watts of it. It's about as much energy released as humans would use at our current rate of burning fossil fuels over 500,000 years in 1 second. Come along with us as we do the Coonabarabran virtual solar system drive. So here we are at Mercury. Most people know about Mercury as it's the smallest of the officially recognised planets. It is actually also shrinking. You could argue that every now and then they should come along and take a coat of paint off the Mercury up there, but the amount it's shrinking is probably so small that even a few molecules taken off the edge would be excessive. The core is shrinking, and as a result, the planet's crust is slumping, which creates some interesting geology. And here we are at Venus. Now, the fact that most people know about Venus is that it is hotter than Mercury, even though Mercury is considerably closer to the Sun. That's because it's got an extreme runaway greenhouse effect. However, the other cool fact about Venus is that its day is longer than its year. It actually sort of rotates backwards in a sense because it's so slow. The friction with the atmosphere and the very fast winds changes the speed at which it rotates, so that instead of tidally locking in the same side always facing the Sun, it actually rotates more slowly than it goes round. Well, here we are at the model of Earth. Now, I'm sure you all know more than enough facts about Earth, so I thought rather than doing some fun facts, I would read to you a selection from Carl Sagan's Pale Blue Dot, which he wrote in response to his success in getting NASA to Voyager's camera back towards Earth and see it as a single dot in the vast distance. Consider again that dot. That's here. That's home. That's us. On it, everyone you know, everyone you ever heard of, every person who has ever lived, who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there on a mote of dust suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena, Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe are challenged by this pale point of light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbour life. There is nowhere else, at least in the near future, to which our species could migrate. Visit, yes. Settle, not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another, to perceive and to cherish the pale blue dot, the only home we've ever known. Everyone watching this probably knows a lot of fun facts about Mars because it's been such a focus of attention, so much more research. But the fact I'm going to go with is that Phobos, the inner moon, is quite likely to eventually turn into a ring, and so Mars will be the first terrestrial planet to have a ring because Phobos is getting closer and closer to Mars over time, and it will get inside its Roche limit and be ripped apart and form a sort of miniature version of Saturn's rings. The other interesting thing about Mars is that both the US and China are spending billions of dollars trying to be the first one to get a sample to bring back, but they may actually be beaten by the Japanese, who are sending a mission to Phobos and Mars's other moon, Deimos, and they will collect samples from them, which is much easier because you don't have to take off against the Martian gravity. And there is a possibility that some dust and material from Mars has been thrown up at various times and been collecting on the moons. And so when they get the samples from the moons, they may also get some Martian material, which means that if that happens, they will beat the Chinese and the Americans by probably several years and at about a tenth of the cost. So this is my little protest message. This spot would be roughly where Ceres should be if they had included Ceres or the asteroid belt in general in their virtual tour. They didn't do that. I think that was partially because the funding ran out when there was plans to make it bigger and better. And I just thought, this is such a scenic spot. How good would it be to have Ceres here? Ceres is a remarkable dwarf planet. It's got all these features, signs of having had water on it at one time, which are very strange because it seems to be just too small for a lot of the activity that it shows signs of having had, and we don't understand that. Jupiter, like space, is big, really, really big. 70% of the mass of the solar system that is not in the sun is in Jupiter. So that means that all the other planets, all the moons, all the comets, all the asteroids together have less than half the mass of Jupiter. And the consequence is that almost everything about it is big as well. Enormous long lightning bolts, auroras much larger than anything on Earth, and a magnetic field that puts all the other planets to shame. I have a Saturn, or I should say one of the Saturns, because after Coonabarabran, the road splits and they put all the foremost outer planets, they put them on several different roads, so there are multiple ones. Their distances are a bit hazy. They're not always exactly the right distances because they tried to put them at sites they wanted people to stop at. Now, the fun fact that everyone tends to go with about Saturn, its density is so low that it would float on an ocean if you could find one large enough. But I thought the most interesting thing about Saturn actually is not so much the planet itself, but its moons. And some of those moons are really eccentric oddballs. Two of the moons, Janus and Epimetheus, are basically in the same orbit, and every 4 years they swap places, with one just a little bit further out from Saturn than the other, which is something we do not see anywhere else in the solar system. I'm here at Uranus. Many of you may have been hoping that I would pronounce it the other way, which I'm not going to do, but for your satisfaction, I will point out that it is placed right next to a toilet block. The fun fact that most people talk about with Uranus is that it rotates on its side compared to all the other planets, and compared to the plane of the solar system. There are speculation about the reasons for that, but instead I'm going to go with the fact that deep inside it's thought that it rains diamonds, and that it may have a superionic state which combines features of liquid and solid occurring deep within. Neptune could have similar things said about it to Uranus. They have very similar currents in lots of ways, but I think the more interesting aspect of Neptune is its moons, most particularly Triton, which is by far the largest captured moon in the solar system. It's a captured conch belt object. Instead of forming with the planet, it was acquired by Neptune at some point. It orbits in the reverse direction from the planet, and only captured moons do that. It is by far the largest captured moon in the solar system, and therefore by far the largest moon to orbit in the opposite direction from the way the planet spins. So I'm standing beneath Pluto, which appropriately enough has a bit of trouble standing out against the stars behind it. Now, if I make a comment about whether Pluto is a planet or not, I might have a bit of problems with my camera cursor, so I'm just going to avoid that. But what I will say is that the Pluto-Charon system is an absolutely fascinating system with whatever category you placed in. It's a situation where both Pluto and Charon are tidally locked to each other, so they're always circling each other at the same rate as they rotate. Thanks for coming with us as we travelled along the solar system drive. The area we've been passing through is known as Australia's astronomical capital. Since the establishment of the Anglo-Australian Telescope, the area around it has been protected by regulations limiting unnecessary outdoor lighting. This has preserved the dark skies and caused amateur observatories to spring up around the area, as well as protecting nocturnal wildlife. The solar system drive has helped cement that status as the astronomical capital. I like to think that having local landmarks like this with information about astronomy and identifying astronomy with the area has meant that children growing up in the area feel more attached to astronomy and might even choose a career as astronomers. For everyone else, a journey like this is a great way to learn about the solar system and to get to grasp the sense of scale. We can't all be astronauts, but a journey like this can give us a tiny sense of what it's like to travel through the solar system.